Hello everyone, welcome to my channel. Our next part is structure of atom. Numerical based will be based on dual nature of matter, right? And next will be de Broglie wavelength. De Broglie wavelength, right? And Heisenberg uncertainty principle. So let's see the numerical based on this topic asked in NEET. First question is measurement of the electron position is associated with an uncertain in momentum which is equal to uncertain in momentum is given, right? So it is denoted by delta P. This is called uncertain in momentum, right? Uncertain in momentum is given by delta P value is 1 into 10 raised to of minus 18 grams centimeter per second, right? So, and we know the formula of momentum is mass into velocity. Next is uncertainty in electron velocity is given, right? So, uncertainty in velocity you have to find, that is delta of V. Mass of electron is given, that is equal to 9 into 10 raised to of minus 28 gram, right? So, apply the formula. Delta P is equal to m into delta V. So delta P is given, right? So this is your delta P given to you. So put here 1 into 10 raised to of minus 18. Mass of electron is given 9 into 10 raised to of minus 28 G. So you have to find the delta V. So delta V is equal to 1 into 10 raised to of minus 18 divided by 9 into 10 raised to of minus 28 G. So calculate this one, right? So you will get delta V as 1 into 10 raised to of 9 centimeter per second. So it is asked in 2008. So please write the explanation. Now see the next sum, second one. If uncertainty in position and momentum are equal, uncertainty and momentum in uncertainty in position and momentum are equal. So this value is given. This is your momentum value. Momentum. Uncertainty. And this is the uncertainty moment in position. Uncertainty in position, right? Given, then we have to find the uncertainty position in velocity. This is your uncertainty in velocity, right? So it is also asked in 2008. So let's see. As we know, the uncertainty formula is delta x into delta p is equal to h upon 4 pi, right? Here both are equal. So I will write delta p instead of delta x into delta p is equal to h upon 4 pi. So it will multiply it, then it will be delta p whole square is equal to h upon 4 pi, right? So now, so delta p will be equal to under root of h upon 4 pi. And as we know, change in momentum is nothing but it is mass into velocity. So it is equal to m into delta v is equal to under root of h upon 4 pi, right? So you can find the delta v now. So it will be 1 upon m under root of h upon 4 pi. So this will be the formula for uncertainty in velocity. Uncertainty in velocity. So this is the formula you can use to find the uncertainty of velocity. Right. Now look at the next sum. Look at the third question. So given mass of electron is 9.11, 10 raised to minus 31 kg. Planck constant H is equal to 6.626, 10 raised to minus 34 joule second. Uncertainty involved in the measurement of velocity with a distance. So you have to find the delta V uncertainty in velocity. So distance is given 0.1 angstrom. Right, it is asked in 2006. So let's see the explanation. Use the Heisenberg uncertainty principle. Right, so we know the formula of Heisenberg uncertainty principle. Heisenberg uncertainty principle. Right. So formula is delta x into delta p is equal to h upon 4 pi. So delta x into delta p is nothing but it is delta mass into velocity. It will be equal to h upon 4 pi. So mass is constant. So it will be coming outside and change in velocity is equal to h upon 4 pi. Right. So I have written here given data. This here given data to you. Now put the value. So delta x value we know, right? This is your delta x, right? So put the value. So delta x is nothing but it is 0.1 into angstrom, 10 raised to minus 11. Mass of electron is given 9.11 into 10 raised to minus 31 into delta V is equal to Planck constant is 6.626, 10 raised to minus 34 divided by 4. Pi value we know that is 3.14. So calculate the delta V value. That will be coming out to be 5.79 into 10 raised to 6 meter per second. Right. It is asked in 2006. Now look at the question number 4. The atom of energy of second Bohr orbit of hydrogen. So energy of second Bohr orbit of hydrogen is given by minus 328 kilojoule per mole. Is the energy of fourth. So energy of fourth orbit it is asking about. It is asked in 2005. So let's see the explanation. So as we know that energy is inversely related to the square, right? So E2 upon E4 will be equal to what? N4 square upon N2 square. Now put the value N4. So N is 4, so it will be 4 square upon 2 square. So it is 16 by 4. E2 value we know that is minus of 328 kilojoule per mole divided by E4. So solve it. So E4 will be equal to, this will be 4. So minus 328 upon 4. So it is nothing but it is minus of 82 kilojoule per mole. So this is the energy in the fourth orbit, right? Now see the question number 5. Energy of radiation emitted when the electron fall from n equal to 4 to n equal to 1 in a hydrogen atom will be. So ionization energy of potential of hydrogen is given, that is equal to 2.18 10 raised to of minus 18 joule, and H value we know, Planck constant is 6.625 into 10 raised to of minus 34 joule into second. It is asked in 2004. So let's see the explanation of it. And we know the energy in both orbit is given by, so please remember this formula. En is equal to minus 2.18 into 10 raised to of minus 18 joule divided by n square. For hydrogen Z atomic number is equal to 1. Right, so change in energy is given by E of 4 minus E of 1 is equal to, minus take common, so 2.18 10 raised to of minus 18 divided by 4 square minus of 2.18 10 raised to of minus 18 upon first orbit value square. So minus 2.18 10 raised to of minus 18 is common. So remaining is 1 upon 16 minus of 1. Take the LCM. So minus 2.18 10 raised to of minus 18. So LCM is 16. So 1 minus 16 is nothing but minus 15. So minus minus will become plus. So it will be plus of 2.18 10 raised to of minus 18 divided by 16 into 15. Right. So calculate this value, you will get 2.04 10 raised to of minus 18 joule. So this is the energy value we are getting. Right. And as we know, energy is related by h mu. Right. So you can find easily frequency. This is your frequency. This is your frequency. So frequency equal to delta E upon H. Delta E is nothing but, we have found it, that is 2.04 into 10 raised to of minus 18 joule divided by H value, that is Planck constant, it is given here. So right here 6.625 into 10 raised to of minus 34 joules per second. After calculation, you will get the frequency, that is 3.08 10 raised to of minus 15 per second. 10 raised to 15 per second. So this is the value I have got. It is asked in 2004. Now look at the next sum, sixth one. So sixth question is, in hydrogen atom, energy of first excited state. Energy in the first excited state is given by minus 3.4 electron volt. Then kinetic energy of hydrogen atom. Kinetic energy of hydrogen atom. So you have to find the kinetic energy. It is asked in 2002. So look at the question number 6 explanation. And we know mv square by r. This is your force, centripetal force is equal to jd square upon r square. Right. So 1r and 1r will get cancelled. mv square equal to jd square upon r. So now multiply both side by 1 upon 2. Then you will get mv square by 2 is equal to 1 upon 2 jd square upon r. Right. And as we know, the total energy is equal to kinetic energy plus potential energy. So total energy, it is given in the question, that is minus 3.4. So it is minus 3.4 electron volt. So put the value of kinetic energy 1 upon 2 mv square. plus minus of JD square upon R. So it is minus 3.4 electron volt is equal to 1 upon 2 JD square upon R. Instead of 1 upon 2 MV square, we have used this one first in the kinetic energy formula. So minus of ZE square upon R. So take the LCM, then it will be minus of 2R. ZE square is common. So it will be 1 minus 2. Then it will be minus of ZE square upon 2R equal to minus 3.4 electron volt. This minus and minus will get cancelled. So it is 3.4 electron volt is equal to JD square upon 2R. So this is the kinetic energy for value equal to 3.4 electron volt. Right. It is asked in 2002. Look at the question number 7. So Debroglie wavelength of particle with mass. Mass is given, that is 1 gram. Velocity is given, that is 10 meter per second. 10 meter per second. So you have to find the Debroglie wavelength, that is lambda. So lambda is nothing but it is your Debroglie wavelength. So let's see the explanation. It is asked in 1999. So De-Broglie equation is given by De-Broglie equation is given by lambda is equal to h upon p. So h upon mass into velocity. Right. So you have to find the lambda. So lambda equal to h value we know, that is Planck constant, 6.63 into 10 raised to minus 34 joule into second divided by mass. Mass is 1 gram. Convert into kg. So it is 10 raised to minus 3 kg into velocity is 10. Calculate the value. Lambda is equal to 6.63 into 10 raised to minus 33 meters. So this is the wavelength we have to find. This is the de Broglie wavelength. It is asked in 2099. Now we'll solve the next numerical, 11th one. So Bohr's orbit radius of hydrogen we have to find, right? It is already given, Bohr's orbit radius. So R1 is given 0.530 angstrom, right? N is equal to 1 for first orbit. The radius for the first excited state. So radius for the first excited state. First excited state. You have to find, right? So it means N equal to 2. It is asked in 1998. So let's see the explanation. We use the formula R equal to N square upon Z and radius of atom. To radius of atom. So N value is 2 here for excited state. So it will be 2 square. And hydrogen atomic number is 1 into radius of atom is given 0.530. Right. So calculate it 4 into 0.530. It is equal to 2.120 angstrom. That is equal to R2. Right. So this relation you have to just remember it to find the next radius orbit. Right. Now see the next sum, that is 13. So radius of hydrogen atom in excited state is given. R of H is given 0.53 angstrom. Radius of lithium plus 2 plus you have to find, right? Z atomic number is given, that is 3. So let's see. So Rn formula we know, 0.530 into n square upon z Armstrong. So put the value 0.53. It is already given Armstrong, right? Into n value is 1 here for first orbit. So it is 1 square. Z is given, that is 3. So put here 3. So calculate it, then you will get 0.17 Armstrong. That is radius in the lithium. That's all for today. We'll meet tomorrow in the next part of the structure of atom.